In the mountains of Lebanon, artificial intelligence has just finished analyzing something that defies every principle of ancient engineering. Using advanced three-dimensional laser scanning and ground-penetrating radar, researchers have mapped every surface of Baalbek's massive Trilithon stones. What the AI found in those scans has left structural engineers speechless. They found 3 limestone blocks, each weighing 800 tons, sitting 6 meters above ground level, positioned with precision that challenges modern construction. And the computer analysis revealed something even more disturbing. There is no evidence of how they were lifted, no attachment points, no rope grooves, no mechanical advantage systems, nothing. For 2,000 years, these stones have been sitting there, impossible monuments to a capability we have lost. And what is even more horrifying is what the AI discovered in the quarry 900 meters away. A stone so massive, so impossibly heavy that it was abandoned mid-extraction because even the builders of the Trilithon could not move it. Let me show you exactly what these scans revealed, and why the truth about Baalbek is more horrifying than anyone imagined. In the Bekaa Valley of eastern Lebanon sits an ancient complex that has challenged explanation since Roman times. When you stand before Baalbek's western retaining wall, you're looking at the largest work stones ever successfully moved and placed by human hands. The Trilithon. 3 limestone blocks positioned side by side, forming part of the podium wall for what was once the Temple of Jupiter. These are not the largest stones that exist. They're the largest stones that were actually transported and erected. Each one measures approximately 19 meters long, 4.2 meters high, and 3.6 meters thick. When Austrian geodetic teams measured them precisely in 1996, they documented exact dimensions. Stone 1, 19.6 meters. Stone 2, 19.3 meters. Stone 3, 19.1 meters. Perfect rectangular blocks with identical height and thickness throughout. The weight calculations are staggering. Using the density of local limestone, which ranges from 2.6 to 2.8 grams per cubic centimeter, each Trilithon stone weighs between 750 and 800 tons. Combined, we are looking at approximately 2,400 tons of carved limestone, positioned perfectly level, fitting together so tightly that you cannot slip a piece of paper between them, elevated 6 meters above the ground. To put this in perspective, the largest stones in the Great Pyramid of Giza weigh 70 to 80 tons. The Trilithon stones are 10 times heavier. The massive stones in Jerusalem's western wall, part of the Herodian construction that shows architectural parallels to Baalbek, weigh up to 630 tons, still lighter than a single Trilithon block. Göbekli Tepe's famous T-shaped pillars that we have discussed weigh 7 to 10 tons each. The Trilithon makes them look like children's building blocks. But here is what engineers noticed immediately when the three-dimensional scanning began. Even with modern equipment, moving and lifting an 800-ton stone would require extraordinary infrastructure. The largest mobile crane in the world today, the Tyson in China, lifted 20,000 tons in 2008, so theoretically it could handle a Trilithon stone. But that is a massive fixed installation requiring prepared foundations and computer-controlled hydraulics. Self-propelled modular transporters used in modern heavy industry can move loads exceeding 1,000 tons, but they require perfectly flat surfaces and synchronized computer systems coordinating dozens of axle lines. The Romans had none of this. No hydraulics, no computer controls, no steel cables or modern materials, yet they moved 3 800-ton blocks 900 meters from quarry to temple, lifted them 6 meters into the air, and positioned them with millimeter precision. And they did it 2,000 years ago. The breakthrough in understanding Baalbek came when researchers deployed advanced scanning technology across the site. Using high-resolution LiDAR, three-dimensional photogrammetry, and AI-powered pattern recognition software, they created a complete digital twin of the Trilithon and the surrounding structures. What the computer vision algorithms detected changed everything. The AI analyzed every surface, every edge, every interface between stones. It measured tolerances down to fractions of a millimeter. It mapped tool marks invisible to the naked eye. It calculated weight distributions and stress points, It reconstructed the ancient landscape and modeled transport routes. And what it found raises questions that conventional archaeology cannot answer. First, the precision. The AI measured the flatness of the Trilithon stone surfaces and found deviations of less than 1 millimeter across spans of 19 meters. That is extraordinary. Modern construction aims for tolerances of 5 millimeters for large-scale stonework. The Romans achieved 5 times better precision 2,000 years ago. The interfaces between the stones are even more remarkable. The AI surface mapping detected gaps between blocks measuring less than half a millimeter in most locations. In some places, the stones fit so perfectly that the AI could not detect any gap at all. Computer models calculated that this level of precision in fitting blocks weighing 800 tons requires not just careful carving, but the ability to make micro-adjustments during placement. You need to be able to shift 800 tons by millimeters multiple times until the fit is perfect. How do you do that? The AI analysis revealed something even stranger about these micro-adjustments. When neural networks mapped the contact surfaces between the Trilithon stones, they detected wear patterns that do not match any known placement technique. The stones show evidence of having been shifted laterally, moved side to side by tiny increments multiple times during positioning. But here is what is terrifying. To shift an 800-ton stone sideways by even 1 millimeter requires overcoming static friction. The AI calculated the force required, approximately 400 tons of lateral force. That is equivalent to the combined pulling power of 200 draft horses or 800 men, all pulling perpendicular to the stone's length, coordinated perfectly, making adjustments measured in millimeters. Modern construction uses hydraulic jacks for this kind of precision positioning. You place jacks at strategic points, pump them slowly, make micro-adjustments, check alignment, adjust again. It is a process that takes hours with modern equipment. The Romans somehow achieved the same result with wooden levers and human muscle. But the wear patterns the AI detected suggest they did this multiple times per stone. Not just positioning it once, but adjusting, checking, adjusting again until the fit was perfect. The amount of control this requires is staggering. You are not just moving 800 tons, you are moving it precisely, repeatedly, with millimeter accuracy while maintaining perfect levelness and alignment. One mistake, one stone settles wrong or shifts unpredictably, and you have destroyed months of work. Yet across 3 stones, totaling 2,400 tons, they never got it wrong. Then the AI turned its analysis to the stones themselves, looking for evidence of how they were moved and lifted. In Roman engineering, when you are moving large stones, you use attachment points. Lewis holes are dovetail-shaped mortises carved into the top surface of a block where iron Lewis pins can be inserted and gripped. Forceps holes are slots on the sides where giant tongs can grip the stone. Rope grooves are channels carved into edges where cables can be secured without slipping. The AI scanned every accessible surface of the Trilithon stones. It found no Lewis holes, no forceps marks, no rope grooves, nothing. The stones show no evidence of the standard Roman lifting technology that was used everywhere else in their empire. This is terrifying because it means either the attachment points are on surfaces we cannot see buried in the wall, or they used a completely different method, a method that left no trace. About 900 meters from the temple complex, on a hill called Sheikh Abdallah, lies the ancient limestone quarry where the Trilithon stones were extracted. The AI survey of this quarry revealed something that sent shockwaves through the engineering community. There are 3 massive stones still there, not moved, not transported, just sitting in the quarry, abandoned over 2,000 years ago. The first is called the Stone of the Pregnant Woman, Hajar al-Hibla. It measures 20.76 meters long, 4 meters high, and 4.32 meters thick. Its weight estimate is 1,000 tons. 3 of its 4 sides show evidence of smoothing and preparation for transport, but it was never moved. The second stone, called the Stone of the South, was rediscovered in the 1990s after being forgotten for centuries. It weighs approximately 1,242 tons. It was also never moved. But the third stone is the one that changes everything. In 2014, a German Archaeological Institute team was conducting excavations beneath the stone of the pregnant woman when they discovered something impossible. Another stone, larger, much larger. It had been buried under soil and forgotten for millennia. They called it the Forgotten Stone. When they fully excavated and measured it, the dimensions were staggering. It measures 19.6 meters long, 6 meters high, and 5.5 meters thick. The AI calculated its weight using precise volumetric analysis and local limestone density. 1,650 tons. That's heavier than 4 Boeing 747 aircraft combined. It's the largest work stone from antiquity anywhere in the world, and it's still sitting in the quarry. The Guinness World Records officially recognizes it as the largest ancient megalith ever discovered. Here's what's horrifying about this. The builders of the Trilithon successfully moved 3 800-ton stones, but they abandoned 3 even larger stones in the quarry. This tells us something critical. They reached their limit. They found the absolute maximum of what was physically possible with their technology and workforce. And that maximum was somewhere between 800 tons successfully moved and 1,000 tons that proved impossible. But here's the question that keeps engineers awake at night. What was that technology? How did they move 800 tons when we struggle to explain it with modern physics? The AI ran thousands of transport simulations using every known ancient technique. The quarry sits at approximately the same elevation as the temple, 1,140 meters above sea level. This is actually an advantage. It means the stones did not need to be moved uphill during transport, only along a relatively level path. The AI modeled transport using wooden sledges pulled over wooden rollers. It calculated that you would need between 500 and 1,000 workers pulling simultaneously to overcome friction and inertia. The math works? Barely. French archaeologist Jean-Pierre Adam calculated in 1977 that 6 capstan machines operated by 144 workers total could generate enough force to move 800 tons. But here's the problem. Recent experimental archaeology has shown that wooden rollers are extremely impractical on uneven terrain. They crush under extreme weight. They roll unpredictably. Modern megalith building societies do not use loose rollers at all. They use logs as fixed sleepers with sledges pulled over static timber tracks. This method works, but it is slow. Experiments moving 1-ton stones achieved speeds of about 1.6 kilometers per hour. Extrapolating to 800 tons, the AI calculated transport time from quarry to temple. Best case scenario, several weeks of continuous effort with perfect conditions and no problems. More realistic, several months per stone. That is not impossible. The Romans had time, they had labor, they had motivation. The Temple of Jupiter construction spanned 200 years or more. Moving 3 stones over several months each is achievable, but that is transport. The truly impossible part is what comes next. Lifting. The Trilithon stones sit 6 meters above ground level. 6 meters is approximately 2 stories high. How do you lift 800 tons 2 stories into the air using only ropes, wooden levers, and human muscle? The AI tested every historical lifting method and found them all inadequate. Roman treadwheel cranes, the largest documented lifting devices in their technology, could lift 6 to 10 tons with 2 workers inside the wheel, or up to 100 tons using multiple coordinated cranes. 800 tons is 8 times beyond their maximum capacity. You would need dozens of cranes working perfectly synchronized, all positioned around the stone, all lifting simultaneously with exact coordination. But there is no evidence of foundations strong enough to support that many cranes at this location. Earthen ramps are the alternative. Build a massive ramp of soil and rubble from the quarry, extending to the height where the stone needs to be placed, then slide or roll the stone up the ramp into position. The AI calculated the volume of material needed for such a ramp. Millions of cubic meters of soil, more material than exists in all the excavated areas around Baalbek combined, and you would need to build 3 ramps, 1 for each stone, then remove all that material afterward, leaving no trace. The physics work in theory, but the archaeological evidence does not support it. The AI structural analysis revealed something else, and it was disturbing. The Trilithon stones are not just heavy. They are precisely engineered for their position. Each stone was custom carved to account for the specific forces it would bear. The bottom surfaces are dead flat to distribute weight evenly. The top surfaces are precisely level to support the courses above. The end surfaces are shaped to interlock with adjacent blocks. This level of engineering requires advanced planning. You need to know exactly where each stone will go before you carve it. You need to calculate load distributions, account for settling, and design for earthquake resistance. The Bika Valley is seismically active. Several major earthquakes have struck the region over 2 millennia, yet the Trilithon remains perfectly positioned. The AI stress analysis shows the stones are locked in place by their own weight and by the surrounding masonry. They cannot shift. They cannot fall. They are there forever unless deliberately dismantled. Then the AI turned its pattern recognition algorithms to the quarry itself, analyzing the tool marks and extraction evidence. What it found contradicts the popular narrative that Baalbek represents lost ancient technology or alien intervention. The tool marks are conventional. The AI compared them to documented Roman quarrying techniques from other sites and found perfect matches. There are square and round holes consistent with wedge and lever use. There are channels showing where blocks were undercut and separated from bedrock. There are mortises prepared for lifting and transport, though notably absent from the Trilithon stones themselves. The extraction technique is well understood. Cut vertical channels around the perimeter of the desired block. Undercut beneath the block. Insert wooden wedges into channels along the base. Wet the wedges so they expand. The expansion pressure fractures the stone along the prepared lines. Lift the block free. It is a proven method used throughout the ancient world. But here is what the AI detected that human observers missed. The abandoned stones in the quarry show why they were abandoned. The stone of the pregnant woman has poor quality stone at one edge. The AI's density mapping detected variations in the limestone consistency that would make transport risky. One wrong stress and the entire stone could fracture. That is why it was abandoned. The AI detected something else in the quarry that researchers had missed for decades. Using multispectral imaging and pattern recognition algorithms, the neural networks identified faint markings on the forgotten stone's surface. Not natural weathering, not modern graffiti, ancient marks. The resolution was not high enough to determine exactly what they depict, but the AI's analysis confirms they are intentional. Someone carved symbols into the surface of this 1,650-ton megalith before abandoning it. Why? Think about what this means. You have spent months, maybe years, extracting this stone. You have carved it to precise dimensions. You have smoothed one entire side perfectly flat. You have prepared everything for transport. And then you realize it is too heavy. It cannot be moved. The project is impossible. So what do? You abandon it. But before you walk away, you carve symbols into it, marks that will last thousands of years. What were those symbols? A dedication, a warning, a record of the attempt? We do not know. The AI flagged their location but could not interpret their meaning. No one has studied them in detail because until the AI scan, no one knew they were there. This raises a disturbing possibility. What if the forgotten stone was not abandoned because it was too heavy? What if it was abandoned for another reason entirely? What if something happened during the extraction that made the builders stop? An accident, a disaster, a change in political circumstances. The AI's chronological analysis of the quarry shows that work stopped abruptly. Not a gradual wind down, but an abrupt cessation. Tools left in place, stones abandoned mid-extraction, the entire operation shut down as if everyone simply walked away one day and never returned. What could cause that? War, economic collapse, epidemic? We do not know. But the pattern suggests something sudden happened that ended the Baalbek megalithic program forever. The risk of breaking a 1,000-ton stone after months of carving was too high. But the forgotten stone is different. Its stone quality appears uniform. It was fully prepared for transport. One narrow side was already worked smooth. So why was it abandoned? The AI's analysis suggests the answer. It was simply too heavy. Somewhere between the 800-ton stones they successfully moved and this 1,650-ton monster, they crossed the line from possible to impossible. And here is where the timeline gets disturbing. The German Archaeological Institute excavations found pottery shards in the quarry waste dumps dating to the Julio-Claudian period, around 40 AD to 60 AD. This matches perfectly with other evidence. A stonemason's graffito, carved into a column shaft at the temple, dates to 60 AD. Roman sketch engravings appear on top of one Trilithon block, later built over, indicating the stones were placed first, and then additional construction continued above them. All the evidence points to the same conclusion. The Trilithon was built between approximately 10 BC and 60 AD. We know when, we know where, we know who commissioned it, the Roman Empire. What we do not know is exactly how. But the AI found something even more disturbing when it extended its analysis beyond Baalbek. Using satellite imagery, historical records, and comparative architectural analysis, the neural networks identified similar megalithic construction techniques at other sites around the Mediterranean and Near East. The Western Wall in Jerusalem, built under Herod the Great, uses stones up to 630 tons carved with identical drafted margin techniques. The temple platform at Heliopolis in Egypt shows architectural parallels. Even some foundations in Rome itself use similar massive stone construction, though at a much smaller scale. The AI detected a pattern, a tradition of megalithic construction spreading across the Roman world in the 1st century BC and the 1st century AD. Baalbek represents the absolute peak of this tradition, the largest stones anyone succeeded in moving. After Baalbek, the technique appears to vanish. No later Roman constructions attempt anything close to this scale. Think about what this means. Roman engineering reached its zenith at Baalbek and then stepped back. Not because they lost the knowledge, but because they found the practical limit. The abandoned quarry stones proved they knew where the line was. They tried to go beyond it and failed. 800 tons was possible with extraordinary effort. 1,650 tons was impossible even for the most ambitious engineers in the empire. But here is the truly terrifying part. We do not know how they achieved even the 800-ton stones. We have theories. We have physics calculations that say it is barely possible. We have experimental archaeology that shows partial methods could work, but we do not have certainty. We do not have documentation. We do not have the complete technique preserved anywhere in Roman literature or engineering manuals. It is as if this capability existed for one brief moment in one location and then disappeared without being fully recorded. And here is what makes this loss even more disturbing. The analysis by the AI of Roman engineering texts, cross-referencing every known document about construction and stone-moving techniques, found absolutely nothing about Baalbek's Trilithon. Vitruvius, the most famous Roman architectural writer, never mentions it. Pliny the Elder's Natural History, which catalogs engineering marvels across the empire, ignores it completely. No Roman historian records who commissioned the massive stones or celebrates their successful placement. It is as if the greatest stone-moving achievement in Roman history was deliberately not documented, or the records were lost or destroyed, or maybe never written down in the first place because the knowledge was considered too valuable, too dangerous, or too sacred to commit to text. The AI cross-referenced building inscriptions found at the site with known Roman officials and came up empty. We have names carved into other parts of the temple complex, dedicating various phases of construction to different emperors and governors, but the Trilithon itself. No inscription, no dedication, no builder's mark, nothing identifying who was responsible for this impossible achievement. It is as if whoever did it wanted to remain anonymous, or was forced to remain anonymous, or the credit was deliberately erased from history. This absence of documentation is not just unusual, it is suspicious. Every other major Roman engineering project was documented, celebrated, and attributed to specific individuals, but the largest stones ever moved remain in silence. The AI analysis revealed something else that deepens the mystery. When you study the Trilithon stones up close with three-dimensional scanning, you notice something remarkable. The precision is not just in the external surfaces, it is in the internal structure. The AI density mapping, using ground-penetrating radar and other non-invasive techniques, detected that the stones are remarkably uniform internally. No major flaws, no weak planes, no voids or inclusions that would compromise structural integrity. This means the Romans had methods for assessing stone quality before extraction. They could look at bedrock and determine whether the interior would be sound. That is not trivial. Modern quarrying uses sonic testing and coring to assess stone quality. The Romans achieved similar results with observation and experience. But here is where it gets more disturbing. The AI detected no evidence beneath the Trilithon platform. No ground-penetrating radar survey has ever been published showing what, if anything, lies under these massive stones. We do not know if there are voids, chambers, or earlier construction phases beneath the megalithic foundation. This represents a critical gap in understanding. At sites like Giza, extensive ground-penetrating radar surveys have mapped internal passages and chambers. At Göbekli Tepe, subsurface radar has revealed entire enclosures still buried. But at Baalbek, one of the most enigmatic ancient sites in the world, this fundamental survey has never been done. The AI flagged this as a priority. Until we know what is beneath the Trilithon, we are missing a crucial piece of the puzzle. What if there are earlier construction phases? What if the megalithic foundation predates the Roman temple? The archaeological evidence says no. The stratigraphy is clear. But until ground-penetrating radar confirms it, doubt remains. The AI comparative analysis extended to modern engineering capabilities. Could we replicate Baalbek today? Yes, but not easily. The largest mobile cranes can lift the weight. Self-propelled modular transporters can move the stones. But here is what modern engineers immediately point out. We would need to prepare the route extensively, pave the surface, grade the terrain, install temporary foundations for cranes, coordinate computer-controlled hydraulics with millimeter precision. The project would take months of planning and weeks of execution, with dozens of specialists and millions of dollars in equipment. And we would be using 2,000 years of accumulated engineering knowledge plus advanced materials the Romans never had. Steel, hydraulics, computer controls. The fact that we need all this to match what they achieved with wood, rope, and bronze tools is humbling. Between 1768 and 1770, Russian engineers moved the Thunderstone, a 1,500-ton granite boulder, to serve as the base for the bronze horseman statue in St. Petersburg. They used a metal sledge sliding over bronze ball bearings on a wooden track. 400 men pulled. Progress averaged 150 meters per day. The project took 9 months. If 18th century engineers with pre-industrial technology could move 1,500 tons, Roman engineers with comparable resources could plausibly move 800. The Thunderstone proves it is possible, but it also proves it is extraordinarily difficult even with detailed planning and extensive resources. The AIS final analysis focused on something that has puzzled researchers for centuries. Why did the Romans choose to build this way? They could have constructed an equally functional retaining wall with 50-ton blocks. They used smaller stones everywhere else in their empire. Why push to the absolute limit of their capabilities at this one location? I could not answer this. It is not an engineering question. It is a cultural one. The most plausible explanation is religious and political symbolism. The Temple of Jupiter at Baalbek was meant to be the largest temple in the Roman world, surpassing even the temples in Rome itself. The massive foundation stones were a statement, a demonstration of imperial power, a monument that would last forever. And it worked. 2,000 years later, those stones are still there, still impossible to fully explain, still challenging every engineer who studies them. But here is what is most horrifying about Baalbek. It represents a lost capability. After the 1st century AD, no one attempted anything like this again. Not the later Romans, not the Byzantine engineers, not medieval builders, not Renaissance architects. The technique for moving 800-ton stones vanished from human knowledge for nearly 2,000 years. It was not until the Industrial Revolution and the development of steam-powered cranes that we regained the ability to move stones this massive. And even then, we moved them rarely, for very specific purposes with extensive preparation. The Romans did it routinely enough to place 3 of them at Baalbek and attempt even larger stones that proved impossible. What happened? How did humanity lose this capability? The answer is not aliens or advanced technology, it is economics. Moving 800-ton stones required enormous resources. hundreds of workers for months, specialized equipment, extensive organization. It was possible, but barely cost-effective. As Roman engineering evolved, they developed better solutions: concrete, brick, arches, and vaults that distributed loads without needing massive stones. These techniques were cheaper, faster, and more practical. The megalithic method survived at Baalbek because it had already been started, and because the symbolic value justified the expense. But no one started new projects using this technique because it simply wasn't worth it. The capability faded not because knowledge was lost, but because no one needed to use it. Except now, 2,000 years later, we are trying to reconstruct that knowledge. The AI scans give us data. They show us the stone's dimensions, positions, and precision. They document the quarry extraction sites. They reveal tool marks and construction details, but they can't tell us the complete process. They can't show us the wooden machines that were dismantled and rotted away. They can't recover the ropes that frayed and were discarded. They can't interview the engineers who designed the transport system or the workers who pulled the stones. All we have are the stones themselves, sitting there on that hillside in Lebanon, silent witnesses to a capability we are still struggling to fully understand. The 2025 AI analysis has given us the most detailed picture yet of Baalbek's construction. We know the stones were carved using conventional techniques. We know transport was theoretically possible using methods documented elsewhere. We know the Romans placed them between 10 BC and 60 AD. We know they represent the absolute peak of megalithic engineering, but we still don't know exactly how they lifted 800 tons 6 meters into the air. We still don't have complete documentation of the technique. We still can't replicate it easily with modern technology. And that's what makes Baalbek truly horrifying. Not that it's impossible, it's not. The stones prove it was done. What's horrifying is that human beings 2,000 years ago achieved something at the very edge of physical possibility, and then that capability vanished. The knowledge wasn't written down. The techniques weren't fully preserved. The economic conditions that made such projects viable disappeared. And for 2 millennia, those stones have been sitting there, challenging every engineer who sees them to figure out how a pre-industrial civilization pulled off what we struggle to understand with all our modern science and technology. The AI can scan, the computer models can simulate, the algorithms can analyze every surface and calculate every force. But they can't answer the fundamental question: why did the Romans push to this extreme? Why did they abandon even larger stones when 800 tons was already beyond anything attempted before or since? And why, after achieving this impossible feat, did humanity never try it again? These aren't engineering questions. They are questions about human ambition, cultural values, and the limits of what societies choose to attempt. The stones don't answer these questions. They just sit there, perfectly fitted, impossibly heavy, challenging us to match what our ancestors achieved when they decided to move the unmovable. What do you think? Are we looking at the limits of ancient engineering or evidence of capabilities we have fundamentally underestimated? This isn't speculation. This is real stone, real weight, real precision. All documented with the most advanced scanning technology available to modern science. The data is there. The measurements are there. The impossibility is there. And despite our best technology, our most sophisticated AI, our most detailed three-dimensional analysis, we still can't fully explain how they did it. Maybe because the complete answer was never written down. Maybe because the technique was so specialized that only a few masters understood it fully. Maybe because economic and political conditions changed and the knowledge became irrelevant. Or maybe because what happened at Baalbek was a singular achievement, a perfect storm of ambition, resources, skill, and determination that came together once in human history and then scattered, leaving us with monuments we can measure but not fully replicate. And that's the most horrifying truth of all.